So Matt is a respected and well-known author, instructor, speaker, consultant about all things Python and data. I am hoping to learn a lot here because all I know about polars is it's kind of like Dataframes with dev. That's the entirety of what I know about it. So I'm going to learn a lot here. I hope you do too. We're going to be hanging out afterwards. We're going to be doing some Q&A, right?
Sure.
Sure. Okay.
I don't have anywhere to go.
Okay. Any other questions? Anything I forgot? No. Okay. All right, Matt.
Awesome.
Do it.
Thanks, Tim. That was awesome. And yeah, who's going to PyCon here? Okay. So definitely recommend I think Ned and I met like back in 2004 or 5.
Long time ago. Yeah.
So that's as much as I like the talks at PyCon, and Ned's given some great talks at PyCon, and so have other people. The thing I like most about it is the hallway track to just get to know people and talk to them and people who are working on projects that you're working on. It's pretty awesome. And I guess I could credit a lot of my career to PyCon and the connections that I made there. So yeah, definitely check that out if you're interested. Okay, so let's get going here. We're going to talk about polars. Just by show of hands, who has used polars? Okay. Who knows what polars is? Okay. Who doesn't know what it is other than the animal? Okay, cool. Let's maybe go down a different route. Who has used pandas? Okay, almost everyone. Who has not? Well, that's a different one. Who has not used pandas? Okay, so everyone in here has used pandas. Okay, so yeah, in short, polars is like a library that fixes most of pandas' warts. That would be like a one-sentence explanation of it. So let me just talk a little bit about my background. So when I graduated from school, I started working with natural language processing in Python. This was before a lot of the libraries that existed today. Back around 2006, I made an OLAP engine on top of MonadDB, which is a columnar data store, and Postgres. And then I heard about pandas at PyCon, and I thought, wow, there's a lot of overlap between what pandas was doing and what I was doing at the time. Then I ended up using pandas for various projects, data science-y projects like failure modeling and analytics and machine learning. And around 2011, I kind of started doing training/consulting. So I wrote a book called Learning the Pandas Library. I did some training around Spark and Dataframes in Spark. And then I wrote the second edition of the Pandas Cookbook. And then I wrote Effective Pandas. And then I started using things like QDF, which is basically pandas on top of GPUs, and Modin and polars. And then I wrote Effective Pandas 2, and then recently I wrote Effective Polars. So I got a couple copies here, we'll give those away later. So that's kind of my background, but again, I spend most of my time, well, not most, I spend a good deal of my time, I say, selling snake oil and teaching people to tell lies with data. I help people, a lot of people, that's corporate training. I come across a lot of people who are like, I am not a programmer, but they're like, I'm sitting in front of Jupyter notebooks all day writing things that programmers don't do, apparently. So I feel like I do a lot of covertly teaching software engineering best practices to people who aren't programmers. And then I do a lot of data science training, helping people make models and doing training around that. So if folks want to talk about that, I'm happy to later, after. So here's sort of the outline of what I want to talk about tonight, and I'm very comfortable, if you have a question, just raise your hand, happy to answer it. Or if I don't know the answer, which might be the case, we're in Jupyter, so we might be able to figure it out. So yeah, I'm flexible. My goal here is to help you learn a little bit, and if there's some way I can do that, happy to do that. So basically the outline, I'm going to take a data set and I'm going to kind of go through a process that I would go from like cleaning it up, understanding it, and then maybe learning a little bit about what's going on in there. And along the way, we're going to introduce this Polars library and talk about maybe some best practices and things you can do with that. But since all of us in here have used Pandas, we'll also sort of compare and contrast that with Pandas, because I think that's sort of the elephant in the room for a lot of people, is like, there's this Polars thing, but I use Pandas. What should I use, right? I think a lot of people have that question. Okay. Okay, so in short, Polars created by a fellow named Richie Bank. I've heard Richie describe Polars as a query engine with a Dataframe API, which is a little bit different. I don't think you can really describe Pandas as that. Pandas, I would describe it as a more naive way to manipulate data, right? It's just like, I'm going to make a class, and this class is going to be able to manipulate the data. Whereas Polars is saying, we've got like 50 years of database experience where we have things laid out in tables, and we have things like query optimization and predicate pushdown and projections and all these things that we do with databases that Pandas does some of, but not a lot of. Let's see if we can sort of take some of that knowledge, put it into this library, and then put a data frame layer around it to allow us to do things maybe a little bit smarter than what Pandas would do. So a lot of people say like, well, I've heard people like on social media or whatnot say like, well, it's really easy to learn Polars. You just replace your import Pandas as PD and you say import Polars as PD. That really doesn't work because this is sort of built from the ground up to be a way to get around some of the issues with Pandas. The API is different. It doesn't have the same API. So one of the main things that you need to know about it if you're working with Polars is that it has this notion of what it calls expressions and context. So a context, you can think of something that would like materialize data, and you can think of an expression as a instruction on something that you need to do before you materialize the data, so to speak. And basically you combine these two, like instructions with like materializing your data to get tabular data. And I should say like that, so you know, if Pandas is a way to manipulate tabular data that has rows and columns, Polars is as well. So we're talking about tabular data manipulation here, rows and columns. So if you had something in a spreadsheet, or if you had something in a SQL database, right, that would be rows and columns, and that might be something that you might consider using Polars as a tool to work with that sort of data. Okay, so these context and expressions, they don't exist in Pandas, so that's completely new. Another thing that's new in Polars, and another thing that's nice about Polars is like, Pandas is kind of the de facto API for like data manipulation. Right? And as an advisor for a company, it's like, we are taking the Pandas API and we're scaling it out to big data, right? Where you can take your Pandas API, you can change the import to import something else, but leave all the Pandas code the same, but it will run on like BigQuery or Snowflake, right? And it will take your Pandas code and run it on that without changing it, which is kind of cool because kind of everyone here has used Pandas and data scientists kind of like Pandas, and it's pretty popular. So Pandas has sort of taken over the world, for better or for worse, but again, it hasn't really had a lot of competition from the Python side. I mean, there's been little things here and there, but what I see more is like, we're going to, like Modin is going to take Pandas and run it on multi-core, and this company that I was advising for that Snowflake ended up buying was like, we're going to take Pandas and run it on big data, and then you have things like QPy, which we're going to take Pandas and use the GPU to accelerate it, right? So there's been a lot of effort to sort of say, let's take Pandas API and make it run in other places. And Polars is sort of like a fresh take, where it's like, with the API as is, there's some warts that we can't get around. So I think that's nice that it's like in the open source world, it's great when there's like sort of one way to do things, and Python says there should be preferably only one way to do things, but I think it's also great that there's competition and other libraries that are like pushing things to be better, right? And I heard just the other day that like there's rumblings among Pandas developers that like Pandas might start doing things in a lazy way now because Polars is doing that, and people apparently like that. So lazy evaluation basically means that oftentimes when you're working with data, I mean, some of you might work with magical unicorn fairy data. I don't. Generally, when I work with data, it's messy, and I don't just have to do one thing to it, right? I have to do this whole process of things to clean it up. Anyone else have to do that? Okay. Some of you work with magical unicorn data. That's awesome, right? But most of us don't do that, right? So we have multiple steps, multiple things that we need to do. And traditionally, what I see with the Pandas world is like people will open up a notebook and they'll open up a cell and they'll say, okay, in this cell I'm going to do one thing, right? And they'll make a new cell. In this cell I'm going to do one thing. They're like, oh, I forgot something. I'm going to put it up in this cell up above this one. And they have this 50 different cells. Has anyone seen this in their workplace? Some of you raise your hands. Okay, maybe. Okay. I see that a lot. Like people just like having like notebook overload, like one cell per operation, which is fine. Like you can get things done, but and it is basically running that code as is. Now with Polars, what you can do is you can say we've got all these 50 things that we need to do, but rather than like have each of them run eagerly or as they're called, what we can do is we can chain them up into a series of operations, and then it has a query optimizer, and the query optimizer can say, hey, you're only using 3 of the columns from this CSV file, and you're only using the rows that have this value in this place. So when I read the CSV file, I'm not going to read all the columns. I'm only going to read those 3 columns, and I'm only going to give you the rows that you filtered out, and it can do smart things about that. And then when you do like a group by operation, you say, okay, I'm going to do a group by, and I'm going to, since you've got 12 cores on your machine, I'm going to run it with 12 cores at the same time, running all these group by operations, right? So it can do these things because it has a query optimizer and it's a little bit smart. This is basically due to like lazy evaluation, right? Whereas we would call Pandas eager evaluation, just when you tell it to do something, it goes out and does it, right? So you can do the same code with both, but like if you can do it in a smarter way and it runs faster, for a lot of people that can be pretty important. Okay, also one thing to note is that Polars at its core is written in Rust, and I would say that Pandas is at its core written in, I would say, NumPy and a combination of Python with a Python layer on top of that. And it's because Python is a slow language, right? And when you're dealing with numbers, you want things to go fast. And so in Pandas, we have this NumPy layer, and with Pandas 2, you get a new arrow back in that if you stay in that playground and you do things in that playground, you get basically close to C speeds when you do that. But when you sort of cross back from like the NumPy or the arrow layer back into Python, that's when things start to slow down. So similarly, but in Polars has a core written in Rust, and if you use these expressions to describe what the operations you're going to do, then it can build up the query engine plan and do things in a smart and intelligent way. Again, another thing, because Polars is written in Rust, there's not really anything Python specific about it per se. There is a Python layer on top of that, but I mean, if you looked at the Python layer, it's like, yeah, you could think of JavaScript or some R or some other interface with this, and it would kind of look very similar here. Okay, so so that's an introduction to what Polars is. Let's load some stuff here. So general convention is just to alias this as PL, Polars is PL. I'm importing Pandas as well for some comparisons there. Note that I'm running version 0.20.17. Is this font big enough? Can you see it in the back?
Yeah.
Okay. So note there's a 0 there at the front, right? So this is just buyer beware. I mean, you're not buying anything, but user beware. Like this has not had like a 1.0 release, right? Which is good and bad. It's good in that like the developers on this project are super responsive. And if you're one of those people who likes to like, oh, this isn't happening or this doesn't work for me, like, yeah, like when I wrote my book, I got multiple bugs fixed and they were like super responsive, right? So being responsive is great, but also that it doesn't have a stable API, things can change and break, right? So if you are working at a big company where you've got thousands of people writing tabular manipulation, you just might want to be aware that like if you're using a library that might break on you, that might be problematic. Okay, so I'm going to load some data here. And this is, I guess, my X data. This is the data from Twitter. And yeah, apparently Elon thought that it's bad to export data. So I don't think you can get this data anymore. Like the ability to export your Twitter data, I can't find it anymore. But anyway, I'm gonna analyze my Twitter data here. So here I'm just loading 2 exports of that. We'll kind of come back to this. We'll sort of skip over this code and maybe introduce pullers a little bit differently. So I'm going to combine. I have two different sets here. So I'm just sort of stacking them and putting them into a single data frame here. So it looks something like this. We got like a tweet ID, a permalink, the text of the tweet, when I tweeted it, how many impressions and how many engagements, what the engagement rates was, and a bunch of other like stuff there as well. So like pandas, like there's a column accessor, so a lot of people are like, oh, they have the same interface. Well, they have some overlapping, but it's not actually a lot. So if we just look at the estimated size of this, this is like, what is that, 2.8 megs. So first of all, like, just talk about Pandas is an in-memory tool, right? So in order to use Pandas, the library, not necessarily the API, but the library, you need to be able to fit your data into memory. Pollars is also an in-memory tool, but it has the ability to do streaming. So you can actually have data that's larger than your machine, or larger than your RAM, and work with that. Though I say that support is somewhat experimental or not quite as flushed out as the in-memory support. So another thing to note here, this is like 2.8 megs of data. I gave a version of this previously, and at that time it was 4.3 megs. So that's just another thing to note, like this library is changing, and generally when they make changes to it, they like make it faster or make it use less memory, which is kind of cool. Especially for things that like you have to fit in your memory, and now it's almost half as big as it was before. So given that this needs to fit in memory, one of the things you want to be aware of is like what the types of your data are. So if you're using CSV files, that can be nice that you can read the CSV file and you can like open it up in an editor and look at it. That's probably like the end of the niceness of the CSV file. Like CSV files don't have type information, they don't have like metadata about what's going on there, and it's actually like a non-trivial problem to be able to parse some of these CSV files. So pollars and pandas are going to make a best attempt at doing that. But the types might not be correct. So I've got a bunch of columns here from this data set. I'm going to delete a lot of them or just remove a lot of them. So a lot of them are like promoted tweets, and I've not really like paid to promote tweets. So those are all empty. So I'm just going to sort of ignore those here. And I'm going to take a subset of my tweets here. And so when I pull this out, and again, this looks sort of like Pandas code right here, I can ask it what these types are. And you can see that this says int64, this says string, this says float64. So again, one thing to note is that these are not Python types, right? There is no int64 in Python. There's no float64 in Python. There's a string type in Python, but these are not Python strings. What's going on here again is this is written in Rust, and so there is a Rust library, and Rust Pollars is implementing a API or a standard which is called Arrow. So like Pandas 2.2 uses PyArrow, Rust also uses arrow as a backend, but it's not the same PyArrow, it's a Rust implementation of that. In short, this arrow standard is a way to compactly represent data, tabular data, in a way such that you can pass it around to other processes if you want to without having to do a data copy. It just says like this is a blob of data and presumably Pandas 2.2 or Polars or some R or some other library, if it understands arrow, should be able to like suck that in and work with the data without making a copy of it, working directly with it. Okay, so again, just note these types. A lot of these are 64-bit integers. We'll see that like I probably don't need 64-bit integers for a lot of things. And again, this is using like 2.6 megs here. Okay, so my process, I'm going to kind of walk you through a process. Like if you were to hire me as a consultant and you're like, hey Matt, look at the CSV file and maybe start doing something with it, I'm going to kind of walk through some steps that I would do. So one of the things I would want to do is make sure I have those types correct. And especially if I'm working with CSVs, if you're working with other things that have type information in it, oftentimes, you know, like reading from SQL or reading from a Parquet file, you might have type information. But I'm going to use some Polars code here, and I'm going to say, okay, we're going to select the columns that I care about, and then I'm going to do a further selection here with the select method. So first of all, using this square bracket here, the indexing operation, you can do that with Polars, but in general, folks don't do that. They would use like the select method. And select is a context. Remember, that materializes our data. And then inside of this context, I'm putting this expression here. So this is where this starts to get weird. So like in Pandas, you know, you do something like this on the left-hand side. You say, here's the list of columns that I want. Here I'm saying I have this call function here, and then I'm passing in this type int64, and this is saying I want to select from this data frame every int64 column. Okay, and this is what I get coming out of that. So this is a data frame that just has the integer 64 columns, and in fact, if you look at the representation of this at the top, it actually tells you the type up here. So that's kind of nice, unlike Pandas. Another thing to note, if you're familiar with Pandas, on the left-hand side, Pandas would have an index. There's no index here. So one of the things that Polars did was it got rid of the index. So, you know, there is no index. There's no hierarchical index. There's no hierarchical columns. Those just don't exist in Polars. Okay, so here again, here's my data frame, and let's another thing that is like Pandas is there's a describe context here. So we'll do this describe, and again, if you were to run this in Pandas, you would have the descriptions here in the index. There's no index here. This statistic here is a new column that was created. You can see it's a string column, and it's describing each of these rows. So my point in doing this was kind of to go through these max ones here and say, like, do I really need 64 bits to store like the number of app opens, which was 8, or the number of app installs from my tweets? Probably not, right? I might need a little bit more to like do this media views, but most of these are relatively small. And if I wanted to, I could save some data by using a different type. Another thing to note, in Pandas count has a specific meaning, and it's not probably the meaning that you think of. Most people would say, I'm going to count, you know, a column. It's like how many rows are in a column. This is not, in Pandas, it's not the count of the rows, it's the count of the non-missing values in Pandas. Contrary to that, this count here is the number of rows, and also in Pandas, if you have something missing, it's generally represented with an NA, not available. Sometimes you'll see like a NaN. Polars has both a missing value, which it calls null, and it has an NA value for not a number. So it is possible, though not super common, to have a numeric column that is missing values, i.e. there is not a value in there, and it also has NaN entries in it as well. So those are distinct things that And in Pandas, those are sort of like glommed together. Like NA just represents not a number, but it also represents missing. In polars, that's not the case. So this null count is how many values are missing. You see that there aren't any values missing. And then we have like summary statistics there. Okay, so I said, like, you can do this square bracket stuff, but most people in polars aren't really doing that. They're doing something more like this, right? So this is chaining, and some of you I know have read like my Effective Pandas book, where I talk about like how I think chaining is a practice that forces you. It's a constraint that forces you to write better code, I think that's a great practice to have for Pandas code. If you're using polars, it's even a better practice to have, because chaining is what will enable a query to be optimized, right? And to be able to run this code quicker. And so basically how you do this is you put parentheses around this. This is the same in Pandas. Pandas doesn't have the optimization there, but you just put parentheses around it. Do you have to put parentheses around it? No, you don't. However, like I like to write code that's easy to read. And if I have code that looks like this, to me that looks like a lot of stuff going on there. And my brain's not really big, so it gets confused here. But what I like to do is I like to just, every little step here, I just like to put it on its own line. And then what that does is when I read this, I can come back to this and it looks like a recipe. This is the first thing I'm doing, and then I'm doing this, and then I'm doing this. Makes it really easy to understand. It also makes it really easy to debug, because I can come in here and I can say like, okay, here's my original data frame, here I'm selecting these columns, and from those columns I'm going to select the integer columns, and from this I'm going to describe what's going on there, get some statistics from that. So a lot of people are like, ooh, that's weird, it doesn't look like normal Python. My comment to you is like, try it first. And generally what happens is most people, when they try it, they sort of say, oh, this actually makes my life a lot easier when I write code, when I write Pandas code this way or Polars code. Okay, so again, my goal here is to kind of, can I make this like media views smaller, or maybe this tweet ID smaller? And I don't really have an easy way with like arrow to ask what size it supports, but we can ask NumPy what the limits of integers are. You can say like, what's the limit of an int 8? This is using NumPy, and it says you can go from -128 to 127. So it looks like, this app opens, I could replace with an int 8, app installs could be an int 8. This could, be a binary like true false, it looks like. Tweet ID, probably not, and media views, probably not as well, right? Also, there's unsigned integers as well, so you can say unsigned doesn't have a negative value. So, I might be able to use an unsigned for follows here, and for this data set, that would work. Okay, one of the things to be aware of is, let's say I'm going to take this follows, right? And follows maxes out at 191, and I'm going to cast it to an int 8, which maxes out at 127. So let's run that here, and I get an error. Okay, so let me just talk about what the code is doing here. Again, because the code is different than what we did with Pandas. So here's select. This is going to say I want to choose some columns, and then I'm going to say with columns. So with columns is kind of like the assign method in Pandas. Assign is an awesome method for chaining that allows you to overwrite existing columns or create a new column, and that's basically what with columns is doing. And so here, with columns is, again, this is this context thing, and inside of it is an expression. The expression says, I want to take the follows column, and I want to cast it to an int 8. Now, a thing to note about this is this PL call follows is not referring anywhere to the data that's in that data frame, right? The data in the data frame is in df. PL call is just a function that exists in Pandas. So what this is doing is it's saying, there will be a column called follows in here, and I want you to try and convert that to an 8-bit integer. Okay, it is not, in Pandas it would be like, there's a column and this is it, and we're going to convert this column, right? So that's a little bit different. And then the query planner is going to say, okay, I've been asked to do these things, now I'm going to look for this column and try and do it, right, in its optimized way. Okay, so when we run that, we get a compute error, and this one actually looks pretty nice. It says the conversion from a 64 to 8-bit failed for 2 values. That's kind of nice. Like, this is actually a useful debug tool. Like, it actually tells you what the values were. Really annoying when you have a tool that says that failed, and like it says it failed for like 5 values, but I'm not going to tell you what those values are. I mean, this is actually nice. So we know, like, okay, 149 and 191, it didn't work, right? But we could do like an unsigned int, right? So if I do that works, and I can come down here and look at my describe here and make sure that like my follows didn't break. It shouldn't have broken. If I can find follows, yeah, there it is, right down there, and 191. So it looks like that worked, right? So that's something that I like to do, especially with CSV files. I'm using like an 1/8 the amount of memory for that, which can be pretty important. Another thing to note is like a lot of people, because they're constantly bombarded with like Spark this and big data that, they're like, I need to like use the tools that big data vendors are selling or like cool companies are using. And a lot of people have data that fits on a laptop, right? So if you're trying to use tools that work with distributed computing, it's going to run a lot slower. If you can get it onto a single laptop, you can actually run it a lot faster with a lot less overhead. So here's a 16-bit integer, right? It goes up to 32,000, and I can go through here and I can say, okay, let's media views. We're going to cast that to that, and that looks like that works. And you can see that when I look at my estimated size after doing that, that goes down a little bit, right? I was at 2.6 megs, and now I'm at 2.4 megs. So I can go through that process to just sort of clean up those integer numbers there. Maybe just break for questions? Yeah.
So when you are casting the column, you're not changing the data. This is just.
Yeah.
This is just like a temporary thing.
Yeah. So this is another so I'm going to rephrase your question. You can tell me if I did it, if I'm rephrasing it right. Matt, are you mutating the data when you're doing this? No, I am not. What this is doing is saying, here's my original data, and I'm going to run this process. It's going to give me a new data frame, right? So this is not mutating the original data. And I'm going to say that's actually a good thing, because you want your code to be idempotent. And if you have something that's changing the data, and you try and run it again, and the data's changed, you're not guaranteed to get the same result here. Another reason why this is good, I mean, it might seem like computational-wise, like that's a waste of space. Maybe it is a waste of space, right, that you're keeping around the original data. Another thing that I find that happens to me a lot is like after I've done some sort of analysis or made a model, the pointy-headed boss comes back to me and says, oh, I need you to explain that, or what's going on here, right? If I don't have the original data, it's kind of a pain to do that, or if I've got like 50 cells with different operations spread out, to like unwind those can be really annoying. But if I've written it like in a chain here, I can like literally like look through this and see what's going on. And it makes my life a lot easier. So yeah, this is not mutating the data in general. It is making us new data. So that's another thing to be aware of, right? Because this is small-ish data, right? We don't want to have a lot of copies of the data floating around if we don't need to. And one thing I like to say is like I said, generally I don't have one thing that I need to do to my data. I have a bunch of things. I don't want to keep all of those intermediate steps around. I only want the original data and my final bit of data if I can.
I have a slight follow-up to that.
Okay.
This cast that you did, if you scroll up a little bit, when you cast the follows, it looks like it's 191.0 in that table just above where you currently are.
Oh yeah.
Didn't we cast that to an integer? Why is that showing up as a follow?
Yeah.
Is that because of the describe? Or?
Yeah, so the question here is like, Matt, you casted this, but now it's saying follows as a 64-bit integer. What's going on? The issue here is that we're reporting on like the mean and the standard deviation, which is the floating point numbers. And this is the type of the whole column.
So it's an artifact of the describe?
Yeah,
Okay.
so if we pull off this, right, if we pull off the describe, which is giving us a different data frame here, if we look at this and we look for follows, you can see that it's an 8-bit follows, yeah. Great point, yeah. So again, the describe is not mutating the data, again, it's giving us a different view, and because sort of data frames all the way down, data frames is a handy way to get that information back. Other questions? Okay, so let's look at strings a little bit. Traditionally in Pandas, but prior to like Pandas 2, strings have been kind of a pain in Pandas because Pandas was built on top of NumPy, and NumPy really didn't have a native string type. And so what NumPy did was it said, okay, here's a column of strings, and NumPy is fine to let you stick Python objects inside of a NumPy array. So that's basically what it did. It said, here's a NumPy array, but it's just pointing to Python strings. So in effect, a Pandas string wasn't any more optimized than like a list of strings. That's basically what it was. It gives you some nice conveniences to like basically do like broadcast operations on them, but you're basically kind of in slow Python land when you're doing that. Now Pandas 2.2 does address that with the PyArrow types, and Polars addresses that as well. So here I'm going to say we're going to select the columns that we want to work with, and then I'm going to select these UTF-8 columns. Note that I can also, recently they changed this, so there's a synonym here, you can call it the string type as well. So these are columns that are strings here. So the permalink here, which is like Twitter, and then some ID, and then what the actual string was, and then time, which is not a string, but came in as a string because, again, CSV files are kind of bad because they don't have type information. And I didn't really say this is a time, so it just left it as a string there. So let's sort of explore this a little bit. But before I do this, I'm just going to remember what I did in the last step here. I got like this step of operations, right? I'm going to select the columns that I want to work with, then I'm going to just make these columns unsigned ints and unsigned 8s, and these unsigned 16s, and it looks something like this. So I'm just going to keep working with this chain. So this is another thing I like to do. I'm showing these as all like individual cells, but generally what I'll do is I'll just build up this chain in a single cell, right? And after I do one step, I'll run it, I'll double check that it works, then I'll just come back to it and update it. So I end up just like building this up. I'm showing this as multiple cells, but generally I'll just build this up as I'm going. Okay, so what I'm going to do is I'm going to say, okay, let's take tweet text and let's change those to a different type, a categorical type. So if you have strings with low cardinality, i.e. there is a few strings that are repeated multiple times, Pandas and Polars can make optimizations about that, right? Instead of storing each individual string, what I can do is say, here's the unique strings, we're going to store an index that basically maps into those. So let's see if that works here. And when I do that, you can see that it actually makes me have more data here, right? And the issue probably is that most of my tweets are different and all of the permalinks are different, right? So taking something where everything is different and putting an abstraction layer to keep track of that is actually adding more overhead than what we had. So there is some crossover point where you save from categoricals, and when you they make it actually slower. Okay, so let's look at this permalink thing. Maybe we can deal with that. It looks something like this, right? So this first part of this is all the same, and then it looks like there's a number here. So, if I was really concerned about saving a bunch of memory, I might say, like, let's pull off the header and maybe make that a categorical. It just has one entry, and I could pull off the ID from the end here. So maybe we can go down that a little bit here. So again, here's my string columns. I'm going to make a I'm going to make a expression here. So again, I'm just going to say column is equal to PL column test. Again, note that this is not referring to the data edit. This is not referring to DF, right? It's not referring to the data frame. This is just saying this is a expression. And when I have this, I have like all of these different things that I can do with this expression. So this is kind of similar to like a Pandas series, that there are a bunch of things you can do, but again, I just want to make it clear that this is not referring to the data. This is just saying we're going to build up some operation on this column or sequence of columns, right? And so because some of these are string columns, like these are all strings, similar to Pandas, there is a string, I would call this like an attribute that's actually a namespace, right? So if we look at like, type here, print the len of the dir. Let's look at the attributes of column here. How many attributes? There's like 260 things that you can do with that, right? But if you like stick on like str on that, there's another 80 things you can do off of strings, right? And then there's like dt as well for dates, right? And then there's like cat for cat, and then there's also like lists and arrays that do things as well. So not only are there those 200 things, but there are also further things that are accessed by these accessors from in there. So again, if you're in Jupyter, you can pull up the documentation here, like what the, again, remember my goal is I'm going to try and extract that digit from that text, right? It's kind of silly, but you know, sometimes you do want to pull something out of a string, and it turns out that you can do that in pullers here. So one of the 70 things you can do with a string is you can do extract, right? So here's a regular expression. I'm going to say I want to pull off this capture group that has a digit in it, and then I want to cast that to a 64-bit integer, and I'm going to say alias ID. So that alias is basically going to say this is what the column name of the result will be. And if we look over here on the side, you can see that there's now a 6 ID entry right over there. So that might be a way to like save some memory there. So here I'm going to just put this into like a little pattern here, and I'm going to say, okay, let's also pull off the URL. So can we do that? Yeah, so there's the URL. Again, that's not particularly interesting, but it might be the case that URLs change, or maybe it changes from Twitter to X over time or something like that. Okay, so now once I have that, I can just sort of, so note up here, this was using the select context to do this, right? Once I have that sort of debugged and it's working how I want, I can just take this expression and stick it into my with columns. Right, so I can use select to focus on one, and then I stick it back in with the with columns here. Okay, so at this point I should have the URL over here, and that looks like that works. Okay, so if I look at this, you know, I'm now down to like 1.8 megs from doing that. So again, this is the process that I might go through if I'm cleaning up my data. Another thing you'll note here is that I did stick this final columns in here, so I did stick a select at the end. This is kind of so I was actually talking to the creator of Pullers, and because I was giving a workshop, and he was like, "Can I actually look at your workshop? You want to like dog through my workshop?" I'm sure, yeah, you can look through it. He was giving me some ideas and like hints on like, you know, what Pullers could take advantage of. And one of the things that he said is, in my chain, I had like a drop at the end. Like I had all these things, and then the very last thing I had a drop. And he's like, you know what? You should actually change that drop, and instead of being negative, specifying what you don't want, you should be positive and specify what you do want. That kind of accomplishes two things. One is readability, right? If I look at my chain and the last thing in it is a select, that tells me exactly what I want, which is especially important if anyone's making like machine learning pipelines or something like that, and your schema changes, you can be specific and only select what you need, right? If you're using a drop and they add something to it, your code probably is going to break, right? The other thing is that it lets the query optimizer do things about it because you're telling it what it has, right? And so it can know what it needs to look for. So I think that's just a good thing. You know, generally we talk about testing, how do I test things, and oftentimes we say the boundaries, right? And one of the common complaints is like, how do I test these data frame things? And I'm still sort of coming to like terms with what I think best practices are about that, but I think one of the good things is we can say like, these are the columns that are coming into this, and these are the columns that are coming out of this. So we can look at that and quickly understand what's going on. Another thing, just sort of rant, right? A lot of people are like, I want to write the least code as possible, right? And when I'm teaching a course, I say, that's actually not what you want to do. You don't want to write the least code possible, and actually, you want to make it so your code is easy to understand for a specific audience, right? And so it's oftentimes making your code easier to understand might require typing more, right? So that's something that I just like to stick in there at the end, is like the columns that I want. Okay, we talked about missing data a little bit. Again, there is a notion in polars of null, which means there is no value here, and nan, which means that it is not a number. And it is possible, again, to have a numeric column with both null values and nan values in it, though in practice it's a little bit hard to get that. Okay, so let's look and see. So here's my chain of what I had up here, and I'm just going to tack on this null count. Okay, so this is a convenience context there. It just says, okay, what's the null count? There's nothing that's missing here. Okay, so I'm not missing any values. Let's try this. Let's see where we have missing nans. And there isn't a nan count, which is kind of weird, but there isn't a nan count in there. So to do that, I need to do something like this. So what I'm going to do is I'm going to say select, and then I'm going to say PL call, and then inside that I'm going to put final columns. So again, this is a little bit different. I'm not just passing a single column in there. I'm passing multiple columns, and I'm saying, okay, are any of those nan? And when I do that, I get this error, and it says like, this is not supported for D-type string. Okay, so that's like, that's kind of annoying. So how do I get around this? I'm just going to show this code. This is what I had before, and this is what I'm going to do now. I'm going to replace the select, and instead of saying final columns, I'm going to say CS numeric. So another thing that Polars has in it is this module called selectors, which is a convenience module that allows you to choose columns. I can say I want like string columns, or I want numeric columns, or I want Boolean columns, or date columns, and then you can do like ands and ors and combine those and do set differences and that sort of thing with them. So here I'm just saying, just give me the numeric ones, and then are those nan, and then sum those. And it looks like I do actually have some missing engagement rates in here. Okay, so that might be something that, if I'm making a machine learning model, certain algorithms don't work with missing values, so you might need to, fill those in or drop those or take an appropriate action with them. Okay, questions up to this point? Yeah.
So I wonder what we can do if we want to parse and cast the data in the fields that we see as strings, using another letter like pendulum or something like that.
Okay, so I'm gonna talk about dates in the next section here.
Awesome.
Yeah.
I just wanted to revisit the comment that you made about testing. Like I see the numbers going down, which is nice.
Uh-huh.
And I'm just wondering, like, if you is there something inherent in polars that would like help you figure out whether you broke something?
Yeah. The question is there something inherent that would tell you whether you broke something? Like, for one thing, like it won't let me do an illegal cast, right?
Okay.
So we do have that. But other than that, there's not really like guardrails where I specify some sort of schema and it's like you're violating the schema. I mean, like if it's a number and I try and do like some string operation, obviously it's going to complain about that, right? But when I was talking about testing, I'm more like, okay, we want to maybe say that like, we have this column here, all the numbers are positive, and their median value is somewhere in this range or something like that, right? So using some tool like Great Expectations might allow me to do something like that, right?
Okay.
Which is kind of where I was going, like putting in checks around my data rather than just like making sure that my conversions don't fail.
Yeah, cool. Thank you.
Just one with just one more thing with the chaining. It's this is still for the optimize, like Polar's ability to optimize stuff, correct? Or are we just still doing this for readability?
Okay, great. So the question is chaining just for polars to optimize, or are we doing it for readability? So Actually, right now, we're only doing it for readability because I'm actually now running pullers in lazy mode. So to run pullers in lazy mode, I would have to come up here and do something like this and stick in like a lazy right here. And then it would say, okay, here's your query plan, and then at the end here I can come in and say like, I want to collect this and actually want to run this, right? Or if I'm, at the top I said read CSV, there's actually a lazy version of that called scan CSV, and I can stick scan CSV at the top of this chain, and then again it can be smart and say, oh, you're only looking at these columns, I'm only going to pull out those columns when I read the CSV file.
That's cool, thank you.
Yeah. Other questions? Yeah.
So you mentioned that in Polars we have two types of checks for ending and for time.
Mm-hmm.
In Pandas, we just did previous and to report. Like, how do we do that? Those checks
In Pandas?
in Polars.
So the question is, how do I do it is null, right? So there's an is null, and that will give me the missing values. There's also an is nan, which will give me the nan values.
So there are two different checks we have to do in
Mhm.
Polars.
Yeah. Yeah, two checks. Yep, they are different. Okay, so there's a question about dates here, so let's talk about that. Again, remember I have this replaced, so if I want to pull the documentation for that, I can. I might be using that for like checking my dates here. So here is my code here, and I got an error. Let's see what my error is. It says I got a conversion error, right? So here, if you look at my code, you can see I said take that time column and cast it to a date. And it said, no, that doesn't work. Right? And then it says, here's some examples here, and then it gives me some hints. Turns out that oftentimes I found the easiest way is to have like a formatting string, like a strf time string that defines the string here. So here I'm going to say, instead of cast there, I'm going to say off of stir, the stir accessor, there's the stir p time, which is going to parse the time, and I'm going to say, okay, I'm going to convert it into a date time, and this is the format for that. And let's run that, and I get a failure here. And it says, no, this doesn't work here, and it failed for these columns here. And here's the examples when it failed. Okay, so I might want to like actually pull out my, so at this point I'm like, okay, maybe I need to look at the data, right? And so here's one of the dates here, and then it turns out here's another date here. So this might have been a little bit confusing, but at the top when I had two different data sets, I had one that I like exported 2 years ago, and then a recent one that I exported before Elon took the ability away, and they had different formats in them. So because I merged those, probably shouldn't have done that, but I did it, and so I kind of need to clean that up. So I'm going to clean that up a little bit here, and so I'm going to have this little chain of expressions here to say, okay, if I've got, this plus 0, 0, I'm going to replace that with nothing, and if I have this offset, I'm going to replace that with nothing, and then let's try this now. And it looks like that works at this point. So you can see that, again, I'm just sort of chaining these operations in there, and Polars is smart about that. Another thing to realize here is like Polars connect with columns. Polars can run all these individually at the same time, depending on how many cores I have, right? So if I've got 8 cores on my machine, it doesn't have to go through them sequentially. It can be smart about those and do those at the same time. Okay, if I want to convert that to Denver time zone, since I live in Salt Lake, I do this, DT, convert time zone. So again, like Pandas, there's this DT, but most of the things in there are a little bit different. So I'm going to say, okay, let's first remove the time zone or put it in UTC time and then convert it to Denver time zone. And you can see that it actually says that it's in Denver time zone right up there. Okay, so again, nothing to note, like this chain has been like this chain that I've been working on this whole time, right? I'm not like making a new data frame. I'm just building this up as I'm going. And if you've got a lot of data, it takes a long time, maybe you come up here and you say like sample, to just sample some subset of those and build it up before you do the final run through. Okay, at this point, this is another thing that a lot of people don't do when they're working in notebooks is like make a function. They're like, what's a function, right? A lot of people who are working in notebooks just do everything at the global level, which is okay. But once you want to start testing something, or you want to pull it out or put it in a library, again, you kind of need to start using software engineering best practices, and generally, like globals are considered bad. So if you've written a chain, it actually makes it really easy to put this into a function, right? You just make a function and you like plop everything into the chain, basically. So let's run that and make sure that that works. It looks like it does work. Generally, at this point, what I like to do is I like to take this code here, and I like to put it at the very top of my notebook. So when I come back to my notebook, I've got like one cell that says load my libraries, another cell that loads my raw data, and the next cell that cleans up my data. Then I don't have to fish through 50 different cells, making sure I run them in the correct order to get my data. It's just all there at the top, and when I come back to it in 6 months, it's really easy to read and come back to it, right? I don't have to roll the dice and figure out what's going on there. Okay, another thing I like to do is, I have been using this alias up here, like saying aliases is URL. I actually don't like that. So again, this is like a readability rant, and I get that some of these things are like, this is the way that Matt does it, which is kind of weird, but I actually like to, instead of using alias, to use a keyword argument here and say URL is equal to that. I just think it makes it a little bit easier. When I see this keyword right here, it looks like, okay, I'm making a URL, right? And I know what's going on instead of I have to get to the end and know what the column name is. I think that makes it a little bit easier to go on. I actually said alias here, so I should probably take that off. But yeah. Okay, another thing, like I did put in select final columns as my last thing up here. And I've got this like list comprehension here to get the final columns. Alternatively, like if you don't have the final columns, generally I think like using drop is kind of an anti-pattern, even though it is available. If I'm really lazy and I don't want to type out all the columns, like I'll use a drop to get the columns that I want, and then I'll list the columns, and then I'll go back and convert that drop into a select to be positive about the ones I want. Right? It just makes it really easy to look at your code and see what's going on there. Okay. So again, I am like showing the size here. Not that the size is the one thing that matters, but like by going through this, we've refined the data a little bit, but we're actually saving some space as well. Okay. Questions up to this point? I feel like I'm getting a little long-winded tonight. Okay. We doing okay? We need to stand up and stretch. We need to have Ned lead us through some stretching exercise. Okay, so chaining, I've kind of ranted about this, so I'm not going to like rant too much more, but again, if you haven't tried it with Pandas, I encourage you to try it. Generally, it makes your life a lot easier. So again, this would be probably my original code that I would stick up at the top here, which is all in one cell. And a lot of people say like, look at that, how long it is, or it's hard to read. Yeah, it is long, right? But it's not 20 cells, it's all in one cell. And because it's formatted how it is, I can just like read through it and I can say, okay, here's a list of columns, here's a regular expression pattern, here's our final columns. I'm going to initially select those columns at the top, and then I'm going to cast these columns to unsigned eighths, these to 16-bit integers. I'm going to pull off the URL, I'm going to convert the time, and then I'm going to select these final columns. Right? I can read through that, and even though there is code there, like procedurally, like the structure of that makes sense. Another thing you can do with this is a lot of people are like, Matt, like, how do I debug that? And a lot of people see like the final chain that I've created, but they don't see the process that I went through to create the chain, right? And so I've kind of shown you the process that I've gone through to create the chain, and I've been debugging it kind of as I'm going along. But a lot of people are like, well, if you chain, you can't debug. Now I have to come in and debug someone else's code. I don't really buy that. Like my take is like, if I want to debug the code, first of all, it should be a lot easier to read. Second, like I can just comment it out and run it up to the comment and like step through that. That's super easy. Another thing is I can just stick in, so there's this generic function, or generic method that exists in Pandas as well. It's called pipe, right? And you can pass in a function that accepts the current state of the data frame. This works in Pandas as well. And so if I want to say like, what is going on after this first one right up here? I can say, okay, well let's just stick in a pipe here. And I'm just going to print the shape of my data frame, and this function should return a data frame. So I'm using a short circuit here to say or data frame because print doesn't return anything; it returns none. So if I say or df, this will return the data frame because lambdas are a little bit weak in what they can do. So anyway, what I'm doing is I'm just sticking in these pipes here to print out the shape as I'm going through here. And then I've got this other pipe here. It's like, okay, I have a function called getVar, and what it takes the data frame as the first parameter and this var name, and then I'm just hijacking the globals to stick in the current state of the data frame as that variable. So there should be a variable called df2 when I run this. And then I've got a few more pipes in here. So this is kind of cool, like it tells you like this is the size of the data frame after each of these points, right? And then there is also a df2 in there if I want to. So like the thing that like I can't debug a chain or like I can't get the intermediate state, I don't really buy that. But again, this requires me to use like pipe, and that requires me to use like a function, and that's kind of like functional programming, which is a little bit brain bending for people, where I'm like passing in a lambda. And again, I go back to like, I want to write code that's readable, but I also want code to be readable for my audience. And I think if you're using this in a professional context, right, then like, I don't think it's too much to ask to start learning about things like lambdas and functional programming. A beginner, that might be hard for a beginner, right? But we're not writing for beginners, we're writing for professionals who want to write code that's easy to use and easy to work with. Okay, another thing that I see a lot is people doing apply. And so it's called map elements in polars. But remember we got that border there, where if we cross that border, like in this is the Rust arrow library, in Pandas it's that NumPy or PyArrow library. If we cross that, we slow things down. And you see a lot of blog posts that are like, the coolest thing in Pandas is to be able to apply something, right? And so let's try and like say, okay, I want to calculate engagement rate. It's actually already in there, but just for fun, we'll calculate it again. And I'm going to say, okay, let's take these two columns, engagements and impressions, and I want to call map elements. And look, I have this cool function that takes two things in there. Let's just apply those two functions to those two columns, right? And again, what this is going to do is it's going to pull out those values and stick it into those functions. And it's going to cross our Python Rust interface and be slow. Actually, not even that, it's actually not going to work. And the reason why this doesn't work is because I'm not using it right. How you have to do this in Rust is you have to do something a little bit different. I'm going to say, convert this into a struct, which is actually a column that has both of those inside of it, and then call engagement rate on that, and that's going to get a dictionary in there. So if I do this, it actually works, and I get engagement rate right there. So this one here is the mapped one, and note that it named it engagements. It took the first column that I passed in there and just kept that. And then the second one is the actual engagement rate that Twitter gave me. So I can double check this to see that like those two look the same and they look similar. However, and this is the same in Pandas, like I can just build up this operation here where I just say, I want to divide those two, right? And that works. The context, the expression supports that. The cool thing is that when you do that, it's multiple times faster. Let's see how, there's a lot of like warnings here, but if I can scroll to the bottom here. Oops. So this took like 2.8 milliseconds. This took like 47 microseconds. So whatever that is, it's like 50 times faster, something like that, right? So you want to be sure, like when you are going through that Python Rust boundary, you only do it when you really need to.
Okay. So
Yeah.
in the example, you were passing just one parameter for in the function, so it was failed. So would it run differently and have different time to complete?
So this is saying I'm going to combine it. So I think the question is like, if I wanted to pass in 2, would it be slower than 1?
The previous example,
Yeah.
of this one, that failed. Expecting to have 2 parameters, not 1. You see
Yeah,
the
this one right here.
This is not required.
Yeah.
So you have to also pass the impression.
Yeah. So note that when I'm passing in here is the function, right?
No? Okay.
And this gets called underneath with this, the result of this.
So you can pass actually 2 parameters. Okay.
So if I want to pass in those 2 parameters, the way to do it in polars is to combine them into a struct, and then call map elements with the struct, and then inside of there pull them out of the struct. Does that answer your question?
Just the way it fails, it says that there's only 1 parameter.
Yeah. Yeah, that's because, again, I'm showing, like this would be like if you came from Pandas, you'd think like this is how we would do it in Pandas. It doesn't work in polars that way. Polars has this notion of a struct, which is different.
That makes sense.
Okay, last section here, mastering aggregation. So I think this is the thing, a lot of times this is what your boss wants, right? When they say like, summarize this by this, or give us the result by this, right? So I want to, let's say, like compare impressions by whether it's a response or an original tweet by month, right? So anytime you hear that by, you should start to think, I want to group this, or I want to do some sort of pivot operation, right? And let's see if we can do that in polars, which, long story short, it will do that. So here we go. I'm going to say, let's make a new column called isReply. I'm going to make a new column called month. And I'm just saying, if it starts with the at, then it's a reply. And then month, I can just say, pull off of DT, there's a stir F time, so I can like make that look like whatever I want. So here's a string that just has the month in it. Okay, that's pretty cool. So now I'm going to say, let's group by the month. And we'll take the mean of that. And so this, again, there's no index here, but what this does is it puts that month column in the left-hand side. And then each of these is the mean value, which is a little bit weird, like what's the mean value for tweet text? It put null there, right? Another thing to note is like this says 2010, this says 2022 9, this is 2012. Let me just run this again. So I'm getting different results here. What's going on? Why are my results different? Yeah, yes, it's not sorted, yeah.
Ascending or descending?
It's not ascending or descending, but in Pandas this would be sorted, right? So why isn't Polar sorting this?
Because of the column?
There's no index.
Index.
Well, there's no index, yeah. But really what's going on here is because we're using multiple cores, right? Because it's smart about that, it can say like, you have a machine that has 8 cores, it's actually going to make a queue for each core, and it's going to say, this is something you can trivially parallelize, like grouping, right? And it's going to say, okay, here's a group thrown on this core, here's a group thrown on this core. It fills up all these queues, and then if one gets done, it just shovels something out. And then the end is just like, here's all the results, I'm just going to give them to you, right? And if we want them in a certain order, then we kind of need to tell it that we want them in a certain order, right? In this case, we didn't do that. So it just comes back in whatever order you want. So I probably want to combine and do like sort month after that. And then, if I run this multiple times, it stays that way. I'm going to set some color here. And one thing I like to do is just to plot these. So here I'm going to say, let's group by month. And then I'm going to say, let's do ag. This is similar to Pandas. But here I'm passing in this expression here. I say, pull off this column and do the mean, then pull off this column and do the mean, right? And so here we go. Here's for each month, we have impressions and engagements, the mean of those. right? And I've sorted that, so if I run that multiple times, it shouldn't change. One cool thing, recently Polars added plotting. So this is kind of cool. It's very similar to Pandas. Before I had to do like this 2 pandas and then plot. Now I don't have to do that. I just plot right from Polars. This is using the hvplot library. Has anyone used hvplot? Okay. So hvplot's kind of weird. It's kind of like a superset. What it does is it allows you to plot, and you can use different backends. So you can use Bokeh or Plotly or Matplotlib as a backend. So this is using Bokeh, and so the nice thing is like you can come in here and you can like zoom around on this, because this is architected for the web, unlike Matplotlib, it's actually pretty smooth in the browser. But you can plot with Matplotlib if you want to as well. So let's so yeah, again, if you don't sort by the date there, if we try and plot this without sorting by the date, you might get something that looks like this, where it changes, right? So you want to make sure that you are sorting by the date. Now, one thing that's annoying you here is like the dates here are kind of really hard to read here. So we might want to try and fix that. And how I'm going to fix that is instead of doing a group by with this month thing here, I'm going to say let's group by dynamic. Okay, so this is, if you've used Pandas, there's a thing called PD Grouper, which allows you to use an offset alias to do a grouping here. Here I'm going to say I want to group by dynamic, and the column that's dynamic is the time column, and I want to do it at the 1 month frequency. So that string 1MO says group everything based on the time column at the 1 month frequency. Okay, and I got an error here. The error says, this one actually complains. It says, you actually, if you're going to do this group by dynamic, you need to have your data sorted. So it's saying, you're trying to do something and you probably want it sorted, and I'm actually not going to allow you to do it unless you get either explicitly sorted or you tell me that it's already sorted. Okay, so I can actually come in here and I can say, okay, we're going to sort it by time before we do that. Alternatively, you can say set sorted if you know that it's already sorted. Well, the nice thing here is now that if you look at these columns, these are actually not strings like they were before, but they're actually date columns, right? So it can be smart. This is still a date time, so it can be smart about plotting those. Okay, so let's do whether it's a reply or not. So I'm going to add in this is reply, and then I'm going to say I want to sort it by time. I'm going to group by dynamic, and I'm going to stick in this one. This is a little bit different than Pandas. I'm going to say by reply. Okay, and so okay, so this is actually giving me a warning here, right? It says that I should be renamed to group by. So this has changed recently. Let's try that. Okay. So what this is giving me now is it has a time here, but it also has an is reply. So for each of these months, I should have an is reply and an is not reply. So let's try and plot that. And I'm going to stick on. Well, if I try and plot this, I get this weird thing, right, where it's like this zigzag motion here. So what's going on here is that, like, at the same point we have two different values, so that's why it's looking like a zigzag. What I really want to do is pivot this, and so pivoting is like taking a column and rotating up, taking the values from a column and rotating up. And so let's see if I can pivot this. Let me just comment out this code so you can sort of walk through this. This is where it gets a little bit brain bending. So here's our code here, and what I want to do is take this is reply and I want to pivot that up here. Okay, so what I'm going to do is I'm going to say my column should be the is reply column, so I'm going to convert this into a columns up here. My index, again, this is weird, there's no index in Polars, but we say what we want to preserve. The column that we want to preserve is this date column or this time column, and then we want to for each of these impressions and engagements, I want an is reply tacked on to those. Okay, so I keep the time column, and then impressions, I get is replied false and is replied true for each of those. So that's how we do that in polars, which is a little bit different than what you do in pandas. At this point, I can plot it and say, like, I want to look at impressions by replies and non-replies there, and it looks like, you know, if it's not a reply, I get more impressions. Okay, questions about that? Okay, so summary. Talked a lot about types. I think you want to be aware of types. Just another thing in that is that I think a lot of people these days, especially with like AI, are like, I'll just let the AI do it, or I'll have some no-code thing, and I'll just throw my data into no-code. I would caution you to be very wary with that. I was actually from the airplane over here, I was with some people who worked at a large no-code AI company. And they're like, well, there really wasn't a thing as no-code. It was basically mechanical Turks behind the scenes doing everything. But the other thing is that for like machine learning, generally it's well known that if you have better data, you can have simpler models that perform better. So if you're just throwing your data into something and say like, run this fancy deep learning algorithm on it, it's quite possible that like you could use a logistic regression or linear regression and get better results if you have better data. And so I actually do, like I went through each column type, but generally if someone says like, Matt, I need you to work with me or something, I want to go through each column, kind of understand what's going on there, right? And certainly you can like automate some of that, but I think there is value in sort of doing it manually, right? To try and understand the data and understand what's going on there. So fixing the types is one thing, but also when I'm doing that, I really do want to go through that data and understand what's going on there. Chaining, again, I've talked about this. If you're using pandas, I encourage you to try chaining. Most people say that it makes their code much better. For polars, it's going to make your code run faster as well, right? Using apply or map elements is generally slow. You want to be aware when you're crossing that Python boundary, when you're crossing that fast, slow Python boundary. And then these aggregations, certainly powerful. I'd say like the code here, you know, when you start pivoting things, that can be a little bit confusing. Play around with that. Hopefully they'll start to make sense the more you play around with them. Okay, so I've got some books here. I'm going to give these away now. So generally how I do that is I do that by filtering out rows and then filtering out columns from rows. So if you're in a row that has few people, you have a better chance. Okay, so since we're Python here, I'm assuming that most people might want the book here. So Ned's row is going to be row 0. 0, 1, 2, 3, 4, ooh, 5's a good row, 6, and 7, okay? So we're going to go, so what do we need to put in here for rand range if we want to include 7?
8.
8, good, yes. The half open interval, right? Include 0 but not include 7. Okay, and I get an error, I need to import random. Okay, let's try it again. Okay, we're at 2. Raise your hand if you're on row 2, which is the 3rd row. How many people are on that? 3? Okay, so we're going to go from this side here. 0, 1, 2. Okay?
Wow.
So I need to put in what in here? 3, right? Okay, 0. Okay, cool. Let's do it one more time. You can come up and get that after if you want. Do we do 7 or 8? 8, sorry. Okay, row 0. Okay, and we got 0 and 1. Sorry about that. So we'll do 2 here, and do that. Okay, awesome. Thanks, everyone. I've got some stickers here if you want. I made like some Scikit-learn Marios and some XG boots that are like golfing and Matplotlib ones, and some Polar stickers. So if you want some of those, come and get some.
All right. Are there any last questions from for Matt. By the way, what we used to do for giveaways is
Oh,
we would use, no, it's okay. We used to use the Meetup API to pull the RSVPs and then pick randomly from the RSVPs,
Oh.
which was kind of cool because you could show API stuff and also shame the people who said they would be here but were not. Yeah. On the screen. What I was doing while Matt was talking was trying to do that in Polars, and I did pretty well. I got the CSV and I read it in, and then I used Shuffle. Then I got a little tangled up on lists and iterators and whatever, but that was a good way to do it too. All right.
Yamil, I had a question about Arrow. You mentioned it earlier, I was trying to take notes.
Okay.
When I'm using Polars, which version of Arrow versus, it sounded like with Pandas 2.0, they're using PyArrow, or are they both using PyArrow?
Yeah. Okay, so let me see if I make this a little bit more clear. So Arrow is like a standard, and it's like an in-memory standard for like how we're going to lay out tabular data into the RAM, such that I can have an R program or a Python program and say, this is like an Arrow blob of table data. And then I can use R to say, okay, R, you manipulate this Arrow data, and then I might want to pass it off to scikit-learn or to Pandas or to Polars and do further manipulation of that. So Arrow is a standard. Okay. Pandas 2.2 has a library called PyArrow, and there's various releases of that. I believe it's like at 14 or something now. But Pandas 2.2 has an optional backend. So traditionally, Pandas would use NumPy as the backing store. With Pandas 2.2, you can basically say, I want to use Arrow instead, and you get a lot of the benefits of Arrow. Namely, probably the biggest one is that strings have a native data type, but another one is the common thing that people didn't like is that integers can have missing values in NumPy. In Arrow, they can have missing values. So if you're using Pandas 2.2 with the PyArrow backend, you can get integers that have missing values. Okay, so that's Pandas, right? And generally, I would recommend if you're using Pandas and you want Arrow, you want to be using at least Pandas 2.2. Has a bunch of bug fixes in that. Polars is also built on top of Arrow, but it's not using PyArrow, which is a Python implementation of Arrow. It's using a Rust library that implements Arrow. And then there's the Rust API on top of that, and then the Polars Python API kind of sits on top of that. Does that help make things clear?
Yes, that's clear.
Is there one last question?
Yeah, I was just going to ask about like a version of Polars. So my company's been pretty resistant to Polars because they feel it's still too flexible and fluid. I was wondering if you had any context you could give on that.
The Polars is too flexible.
Too fluid, sorry.
As in it's changing too fast? Yeah, so the question is like my company, I want to use Polars, but my company doesn't want to because they're slow laggards.
Yeah.
Sorry, I mean they want, no, I mean there's something to be said about using boring technology, right? And maybe Polars is a little bit exciting right now. Like, I mean, you can see that like, even while I was doing this, like it's like, oh, change, this is deprecated now, right? Yeah, so at some point that's a business decision, right? I mean, I think, you know, there isn't a 1.0 release, which, you know, if I'm a pointy-headed boss, I can say like, there's not even a 1.0 release, we're not going to use this, right?
Well, interesting note to end on. All right, thank you, Matt. We can hang out here for about 20 more minutes. We don't have to